to the problems on assignment number 2. The swimmer does 0.45 meter per second. River is flowing at 0.40 meter per second. The width of the river is 75 meters. And you can use V is delta x by delta t, which gives you delta t is delta x by Vx. Or you can use the same formula for the y component. And again get delta t is delta y by Vy. Now from this, you know delta y is 75 divided by Vy, which is 0.45. To get the time is 167 seconds. And then use it in the other formula, rearrange it, and you know Vx is 0.40. So multiply that with the time that you got, which is 167 seconds, to get 66.67 meter. That's it. Now in the second question, the horizontal component of the velocity does not change. So if we find the horizontal component at B, we will get the horizontal component at A. So let's think about this problem in reverse. Let's imagine that the object is actually going from B to A in reverse. And if that is what it's doing, we know that the initial vertical velocity at B, the initial vertical velocity is 0 because it's only moving horizontally at B. A is 9.8. Remember, we're thinking in reverse now, so it's coming down. And we can find delta t because delta y, the height of the window, is given as 4.5 meter. So use the form that delta y is VOY delta t plus 1/2 A delta t squared. And this whole term is going to become 0. Then 4.5 is, half times 9.8 is 4.9, so 4.9 delta t squared, which gives you delta t as square root of 4.5 by 4.9, which is square root of that that gives 0.96 seconds. 0.96 seconds. Now we know that to find the horizontal displacement, delta x is equal to Vx delta t, and delta x is given as 5 meters, so 5 is equal to Vx times the time that we have, 0.96 seconds, and therefore that gives you Vx as 5 divided by 0.96, that is 5.2 meter per second. Now question 3 is really a trick because it says how does the horizontal component 1 second after launch compare with that 2 seconds after launch, and you know that the horizontal component is constant. Horizontal component of velocity is a constant, never changes. Gravity does not act on the horizontal component, only acts on the vertical. And actually the horizontal component, in this case Vx, is going to be 30 sine 30 degrees, which is going to be 15 meter per second. And again, the moment you launch it, whatever the horizontal component is, it's going to be the same until it falls back to the ground. That's what I'm trying to say. Now in this question, there are three vectors given. The first vector is A, and it's 44 units long, and the angle that it makes is 28. Now, we could resolve this into two components, and you would get the components. Alright, the x component here, that would be 44 cos 28, and the y component would be, the y component here would be 44 sine 28. Right. Now the next vector that's given is B, and that is given along this direction, and the angle that that one makes is 56 degrees. So now we can resolve that into its two components. You have the the y component, this one, and the x component. In this case, this is going to be 26.5 cos 56, and the y component is 26.5 sine 56. And the third vector is completely along the y-axis. It's given completely along the y-axis, and therefore it does not have an x component. It's completely 31, and the x component is 0. So when you look at this, you see that you have one x component here, the second one here, and they are opposite to each other. You have three y components, you have two here, you got to add them up, and this is opposite to that, so subtract. And now I've got the values of each one. And so along the x you have 38.84 and 14.81, so you got to take the difference of those two. 38.84 take away 14.81, that gives about 24. So you would say that you have a total x component of 24, and then the y's, you have 21.96 and 20.65, so 21.96 plus 20.65, when you add those you get 42.61, and then you take away 31 from that to get 11.61. So your y component is going to be 11.61. And then you find the resultant of these two by squaring the two. The resultant vector is going to be the sum of their squares, so 11.61 squared plus 24 squared, and you take the square root, so that will give you the resultant. And that gives 26.67, so you get the vector is 26.67, and then you need to find the angle. The angle is going to be tan theta. As always, tan theta is the y component by the x, so that's 11.6 by 24. The reason you see that way is because if you have this here, I have this is the angle. Remember, this is your 26.67, this whole thing, that's what you got from 24, and this is your 11.61. It's just because it's the opposite side, both of them have the same length. Okay. So when you do that and take the inverse, you must get 28.5 degrees. Therefore, you have the magnitude and the angle that the vector makes. Question 5 is pretty straightforward. You have two vectors. One is 3.5 kilometers and the second is 4 kilometers. Question says, what are the maximum and minimum magnitudes? See, the maximum of any two vectors would be when they are in the same direction. So you get them as V1 plus V2, which would be 3.5, plus 4, which gives 7.5 kilometers. That's going to be the maximum possible. And the minimum vector is going to be when they are opposite to each other. So let's say prime is, of course, it's going to be in the direction of the bigger vector. So it'll be V2 minus V1. And so that will be 4 minus 3.5, which gives you 0.5 kilometers. So that's the maximum of the two vectors, and that's the minimum. Now in the sixth question, you have two vectors. One is 8.5, and it's units long, pointing along the positive 45 degrees to the positive x-axis, which is this one. And then you have 6.6 units pointing along the negative x-axis. So what you do is you break up the 8.5 unit vector into its horizontal component, which is 8.5 cos 45, which gives you 6. And then its vertical is 8.5 sin 45, which is also 6. Now you look at both the x components. So you have two x components. One of them is 6.6, the other is 6. Take the difference, you're going to get 0.6. And that 0.6 is surely going to be in this direction, because that's bigger. And along the y, you only have a 6. So you take the resultant of those two, which would be the sum of the squares of those, which is 0.6 squared plus 6 squared, and take the square root. That is about 6.04 units. In question 7, refer to the diagram. You see that the horizontal component of the velocity is 65 sine 37, which gives 39.1 meter per second. That's the vertical component of the velocity. The initial vertical component is that much. So that is, we'll call it V1. We're only looking at the vertical. A is negative 9.8. It's first going up. And delta y is negative 125 meter. Why is it negative 125? Because it's going further down from where it started. So the initial direction is positive. If it goes further below where it started, it's going to be negative. And then you can use, you were trying to find the time. To find the time, use the king, which would be delta y is v1 delta t plus 1/2 a delta t squared, and get my negative 125 is 39.1 delta t minus 4.9 delta t squared. Well, I wish I had the time to show you how to solve this. I've done several times. Use the quadratic equation, make this a quadratic. It'll become 4.9 delta t squared minus 39.1 delta t minus 125 equal to 0. And when you solve this, you would get delta t as 10.4 seconds. Use the quadratic function, the formula, and solve it. You would get it as 10.4 seconds. Now, that's the A part. In the B part, you're asked to find the range, which is the horizontal distance. And the only formula you can use for that is delta x is Vx times delta t. And since you know that the horizontal component of the velocity when it started was 65 cos 37, which is 51.9. So that'll be 51.9 times 10.4, which we got now, which gives 541 meter. In the C part, you're asked to find the horizontal and vertical components of its velocity at the instant just before the projectile hits P. Now we know that the horizontal component never changes, so the horizontal component of the velocity is still going to be 51.9 just before it hits the ground. But now we got to find the final y component of the velocity, for which we know the initial vertical was 39.1, is negative 9.8, and we also know that the time for which it has been moving is 10.4 seconds. So use the equation. V2 is V1 plus A delta t. Remember, that's our V2. And we're looking for that. So that will be 39.1 minus 9.8 times 10.4. This is going to give you a negative 63.1 meter per second approximately, because this negative part is bigger than this, so you get a negative number. And then in D, you're asked to find the magnitude of the velocity. The magnitude of the velocity is simply the sum of the squares of Vx and Vy. So Vx squared plus Vy squared, that will give you square root 51.9 squared. 51.9 squared plus, well, it's plus negative 63. That's anyways going to become positive. When you solve that, you would get something like 81.7 meter per second. And you also have to find the angle. Now, to find the angle, you just know that the horizontal velocity was 51.9. The vertical was 39.1. So this is the angle you're looking for, theta, and obviously that's tan theta is 39.1 divided by 51.9. And when you find that and take the inverse, you're going to get theta is equal to about 50.6 degrees. And finally, you have to also find the height, maximum height above the cliff. To find the maximum height above the cliff, what you do is you take the vertical. You know the initial vertical velocity is 39.1. At the highest point, the velocity is going to be 0. A is negative 9.8 meter per second squared. Looking for delta y from that point. Again, sorry for that. So you're looking for delta y. And therefore the equation that you use is V2 squared minus V1 squared is equal to 2A delta y. Make delta y the subject. Delta y is going to be v2 squared minus v1 squared divided by 2a. That'll give you 0, take away 39.1 squared by 2 times negative 9.8, and that gives 39.1 squared divided by 19.6, which is what you get. So that is 78 meters above the cliff. That is what you get for F. Now in question 8, what do you have? You have an airplane heading south. So it's heading due south at 600 km per hour, and the wind is blowing from the southwest. So from the southwest, so it's blowing that way at 100 km per hour. So that's 100. Oh, that's 100, and that's 600. Now what you do here is you break this component into, that vector into 100 cos 45, which will give you 70.7 meter per second. And again, the vertical component will be 100 sine 45, which will also be 70.7 meter per second. And then you look at the x-axis. You only have one component, but on the y you have two. So you have 600 and you have 70.7. So you take the difference between those two, and so the vertical component now would be 600 minus 70.7, which gives you 529.3 meter per second. And of course the x component, there's only one, which is 70.7 meter per second. So you got the velocity along the y and the x, and to find the resultant, what you do is you take square root of the sum of the squares of the two. So that's how you find the resultant all the time. And this gives you, how much is that? That's 540 kilometer per hour. And then you have to find the angle. Now, before that, just remember that you have a tiny Vx is 70.7 and Vy is 529.3. Is this right? Yes. Vy. And so you're going to find this angle, theta, and this is Vy, this is Vx, and tan theta is going to be Vy by Vx, which is, plug in the numbers, 529.3 divided by 70.7. Find that out and calculate the angle. When you take the inverse, you're going to get about, is that the 8th one? You get 82.39 degrees south of east. 82.39 degrees south of east. The 9th question, the boat can travel at 2.3 meter per second. Okay, so that's the river, and the boat travels directly at 2.3, and the stream flows at 1.2. So that's 1.2. This is 2.3, and you're asked to find the velocity of the boat relative to the shore. You have your Vy and your Vx, and the velocity relative to the shore would be, again, 2.3 squared plus 1.2 whole squared, which would give you 2.59 meter per second. And then to find the angle, just remember that this is Vx and you have your Vy, so the angle is going to be that. So that's Vx, Vy. So the tangent of your angle is Vy divided by Vx. Gives you 2.3 divided by 1.2, and when you take the inverse, you're going to get 62.4 degrees relative to the shore, because that is where the shore is. That is the shore, okay. 62.4 degrees relative to the shore. And where will it be 3 seconds after? Well, you have the velocities, so just to find where it is, just multiply that velocity, wrong pen, multiply that velocity 2.59 with 3. That gives you 2.59 times 3 is 7.77 meter per second. Oh, I'm sorry, 7.77 meter. Well, the last question talks about, can two vectors of unequal magnitude add up to give a zero vector? No, never. They cannot. Can three unequal vectors add up to 0? Yes, they could. When is that possible? If you have three vectors that when you connect the tip to tail and they form a closed triangle, now you know that there's no result. So vector A, vector B, and vector C together has become 0. They cancel out. So that is possible. Now I did the recording of this one really fast, and I was hard pressed for time, but I hope it helps you out in tomorrow's exam. Thank you.